Hello! In this video, we're going to learn about lists, how to create lists, how to modify lists, how to index lists, how to create lists of lists. We're also going to learn about different data types in Python. To get started, we should create a variable. Creating a variable in Python is easy. You decide on a variable name. Let's just call our variable genus. And then after you decide on a variable name, you give it a value. And to do that, you type an equals sign. Usually, the variable would have a numerical value, but today we're going to be dealing with letters and words. These are called strings. Strings are collections of characters. Let's give our variable the value of vitis, which is the genus name of grapevine. And let's create another variable right now called species, and give that the value of vinifera. Vitis vinifera is the wine grape from which we make wine. So once we have typed our variable names and given them values, to execute a cell in a Jupyter notebook, what you do is you press Shift-Enter. And now genus and species are assigned the values of vitis and vinifera. Now that we have assigned these variables values, if we type the variable and press Shift-Enter, you can see that you get vitis back. But there's a more formal way to do this, and this is called a function. A function is something that takes input values and gives you output values back. Functions in Python have parentheses, and you put the input arguments within the parentheses. So let's type the print function and put in the parentheses, and then put in the variable genus. And you can see it prints the value vitis. You can do a lot more with the print function. You can also specify strings, again, with quotation marks. If we don't put in the quotation marks, we'll be specifying a value, so it's important that we do that. And so let's type the variable genus is equal to end quotation, and then we put a comma, and so we have one string, which is the variable genus is equal to, and then we put our variable genus after a comma, and then we press Shift-Enter, and you can see what is printed out by the print function is the variable genus is equal to vitis. It's important to realize that the quotation marks are the ones that are specifying this to be a string. It is literal, and that is what it is, this precise collection of characters. Whereas with the absence of the quotation marks, it's a variable. The variable will be transformed into a value, vitis, and that's how you get this overall print statement. It really doesn't matter that it's a double quote. You can also use single quotes, and Python really doesn't care. Double or single quotes are equivalent. So that's a function, the print function. There's something called indexing in Python, which is useful to isolate elements of an object. So if we have a string, and let's say we want only some of the characters, but not all of them. Let's say we want the first character. Your first intuition might be, because it's the first character, you would put a 1. And notice here to index genus, we're using square brackets. And then we put the numerical value of what character we want. You might think it might be 1. That might seem logical, but if we press Shift-Enter, after we have put in the 1, we see we get an I and not a V. We were going after V, the first character, and that's because indexing in Python starts with 0. And you must always remember this. So if we want the first character in vitis, we put a 0 because indexing begins with 0, and then we get the V. Indexing can also be used with a colon to give it a start and a stop, and this is not necessarily intuitive either. Let's say that we wanted the whole word vitis. So we just said that indexing starts on 0, so that would be the first character, that would be the start. And if there's 5 characters in vitis, but if we start on 0, the last letter should be 4. And so if we wanted the whole word using a colon, we would have the start and stop of 0 and 4. And you would think we would get to the whole word vitis back, but we don't. Instead, we only go up to the next to last letter. And so you have to remember that indexing in Python starts at 0, but it goes up to not including the last number that you specified. So to get to the whole word, we actually have to go from 0 to 5 because it's not including 5. And so that's how we get 0, 1, 2, 3, and 4th elements of our string vitis, and then eventually get the whole word. Strings are values, and you can do a bit of arithmetic with them. So let's try to put our genus and species together to create the species, Vitis vinifera, the wine grape. So let's create a new variable. We'll call it wine. And we'll take genus, and we will add it to species. And we press Shift-Enter to create our variable wine, and then we print wine to see what we have. And there you go. We have Vitis vinifera, the wine grape. So strings are collections of letters. They can be indexed using square brackets. The indexing starts on 0, always in Python. And it will go up to not including the last number that you specify. So if you want all the elements of the series, you should usually add +1. Let's create a few other variables now. Let's create a variable called tequila, and we will call this the species name of the plant that makes tequila, Agave tequilana. And let's create another variable too, and we'll call it beer. And beer will be equal to the name for barley, which is Hordeum vulgare. And we press Shift-Enter, and we create our 2 new variables. And let's just do a check now to make sure that all our variables are okay. So let's print out the variable wine. We'll print out our new variable tequila, and we'll print out our new variable beer. And you can see that we have the 3 species as strings that contribute to wine, tequila, and beer: Vitis vinifera, Agave tequiliana, and Hordeum vulgare. So that's how you create variables. We've been using strings, which are collections of characters, as the values. Now let's create a list. A list is a collection of variables and different elements. Let's call our new list angiosperms, which you have just learned is the flowering plants. We need to create a list first before we put things into it, and creating an empty list in Python is very easy. All you do is you just put square brackets. The square brackets by themselves are what indicate a list. So if we just Shift-Enter, we have created a new variable, angiosperms, and it's a list. But it's empty. There's nothing in it. So how do we know what it is or that it even is a list? An important function that you can test this with is called type. And type tells you what sort of data type that you're working with. So we just created this new variable, angiosperms, that is supposedly a list. We can now use the function type. We can press Shift-Enter, and there you can see that angiosperms is a list. We can also use this with a variable like wine, and you can see that wine is a string, which is a collection of characters. So now we have our empty list angiosperms. We need to put things into our empty list. So let's put some angiosperms in our list of angiosperms. And we will put the variables wine, tequila, and beer, because the species that make these are all flowering plants. To populate a list, you can put variables, you can put numerical variables, strings, you can put anything you want in it separated by commas. Shift-Enter, and now angiosperms should have elements in it. So if we just type angiosperms, We get now Vitis vinifera, Agave tequiliana, and Ordeum vulgare. They're strings with quotes, and they are in these square brackets. And that is exactly what a list is. You can index a list just like we did for the string. So let's say that we want the first element of angiosperms. We use 0. And the first element of the list angiosperms is the string Vitis vinifera. Let's do this again for the third element, which would be indicated by a 2 using indexing because we start with 0. And that is the third and last element, which is Ordeum vulgare. And again, we can get the whole list back using start and stop. So we start at the first, and we don't go to 2, we go all the way to 3 because it's up to but not including 3. And if we do that, then we get all the elements of our new list. Once you have a list, you can also use indexing to modify the elements in the list. So let's say that we're going to learn after this exercise that not all grapes necessarily come from Vitis vinifera, they come from other species. So maybe we want to replace that first element of Vitis vinifera with just Vitis by itself. To do that, we would use indexing. We would indicate that we want the first element, and all we do is we use an equal sign to reassign a new value. And so let's write over Vitis vinifera with only Vitis. We press Shift-Enter, and so now our list should be modified. And it is. Instead of Vitis vinifera as the first element, we just have the genus alone, just Vitis. Another function that's very useful is length, or len. This will give you the length of a list, like angiosperms. And this is very useful if you have extremely long lists and you forget exactly how many elements you have in it, especially if you're adding or subtracting things from your list, or if you're modifying it all the time, or need to index it. And so if we look at the length of the list angiosperms using the function len, you can see that it has 3 elements. Another important function that is specific to lists is called append. And because this function is specific to lists, it has a little bit of a different notation than we've been seeing for functions before. And what append does is, let's say you want to add more things to your list. Append is very useful. It will add a new element that you specify to the end of an existing list. So to use append, what you do is you type the name of your list that you want to modify, in this case angiosperms, and then you put a period, and then you put append, and then you put the parentheses. And this is because append only modifies lists. And so whatever you put here, we haven't covered sake yet, which is made from rice, which comes from the genus Oryzae. If we use the append function on the list angiosperms for Oryzae and press Shift-Enter, we should have appended to the end of the list angiosperms the element Oryzae. So let's take a look. And indeed, that's the case. So before we only had these 3 elements, but now we have a 4th that we have added using the append function. And again, you can index this as always subtract 1 because we're starting with indexing at 0, and you can see that we get Oryzae. And now if we use the length function on angiosperms, instead of 3 elements, now we have 4. So that's how you create a list. In this particular list, we have only been using strings, but lists can accommodate any data type and any combination of data types within the same list. You can even create lists of lists. So just before this lesson, we were learning about the taxonomy of plants, which is extremely hierarchical. We have the whole group of plants, but within that group are major divisions, and within those divisions are families, and within those families are genera and eventually species. And this is something that works really well with the idea of lists, because that's essentially what taxonomy is. So let's create a whole giant list for all the plants. we are going to call it Plantae. We create our list with square brackets, and then we can put things in it. If you remember, the Plantae are defined by the Archaeplastida, in which a eukaryotic cell engulfed an ancient cyanobacteria, and eventually that cyanobacteria became the chloroplasts that are in the photosynthetic plants. And plants include many different groups. One of them we learned was the glaucophytes. Only 15 species of unicellular freshwater organisms. Then we have the beautiful rhodophytes, which means the red plants, the red algae. We have the chlorophytes, which are mostly marine, but also independently made it onto the land by creating a symbiosis with fungi and many of the lichens, and also are giant unicellular organisms, an alternative to multicellularity. We have the charophytes, which are mostly freshwater algae, and it was from the charophytes that the land plants evolved, although it's very contentious about which charophyte is the one that land plants evolved from. And then we have the land plants. First, we have the non-vascular plants, the bryophytes. These include the mosses, the liverworts, and the hornworts. Bryophytes, the dominant phase of these is the gamidophyte. This is a multicellular haploid organism, and it produces gametes that then fuse to create the diploid, that is, it has two chromosomes, sets of chromosomes, sporophyte. And this tiny sporophyte is what corresponds to the land plants, although it's very tiny and minuscule in the bryophytes. And then we have the pteridophytes, which is where the sporophyte becomes dominant. We have highly branching leaves in the ferns, megaphylls, and these are seedless vascular plants. They have true vasculature. And then we have gymnosperms, and these include ginkgo and the cycads and the conifers. And then finally, we have the angiosperms. But for each of these, we just put a single string. But for the angiosperms, we have already created a list. And so this is how we create a list of lists. And so we press Shift-Enter, and then let's look at what this list of lists Plantae looks like. So we have each of the major groups: glaucophytes, rhodophytes, chlorophytes, charophytes, bryophytes, pteridophytes, gymnosperms. And then we have a list of angiosperms with our 4 different flowering plants that we put in that. This list of lists is a normal list. It works just like all the others. Let's index the first element, so that would be the second in the list, and we should get rhodophytes back. Let's access our list of the angiosperms within our list of Plantae, so that would be 0, 1, 2, 3, 4, 5, 6, 7. And there you go. We have our list of the angiosperms that we get back. But let's say that from this list of lists Plantae, you actually wanted to access a specific element, and we can do that. So we first specify which element of the overall list that we want, which is 7, but then we just put another square brackets and which element within that secondary list that we want. So let's say we want agave, and we get agave tequiliana. And again, let's try to modify this element within now multiple lists. So just like the grapevines, let's say that there's different agave species that make tequila or different mezcals. And so instead of making a specific species, we just want to say the genus agave. We can re-specify it. And then if we look at our list of lists, you can see using these double square brackets, we were able to modify just agave from the species. So we can index still within lists of lists, You just put series of square brackets saying which elements that you want to look at. And so, again, you can even add lists that weren't there before within this master list. So let's make a list of gymnosperms. These include the conifers. They include the cycads. They include cnidophytes. Whoop. We need quotes to create a string. Cnidophytes. And let's create one for bryophytes too. Oh, we don't want the extra comma there. So we create bryophytes, and we include the mosses, the liverworts, and the hornworts. So there we go. Now we have created 2 more lists, and we can modify our Plantae. So the gymnosperms are elements 0, 1, 2, 3, 4, 5, 6. And we now modify the 6th element to be the list of gymnosperms. I misspelled this. Shift enter again. And the mosses, the bryophytes, 0, 1, 2, 3, 4, are element 4. And we specify that we want a list there now. And so now if we look at Plantae, we have modified it quite a bit now. And we've replaced bryophytes with a list of bryophytes, and we've replaced the gymnosperms with a list of gymnosperms. So that's how you create and modify lists. Just to show you that this very complicated list, Plantae is still just simply a list. And now let's talk about different data types. So one data type is a list. This is a compound data type. It's a little more complicated. But more simpler data types are strings, as we saw before. So if we go back to our genus, that was a string. And the other data types besides strings are numbers. And there's 2 different types of numbers. There's integers and there's floating point. Integers are just counting numbers with no fractional component. It's just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and as far as you want to go. Floating points have a decimal, and they have something after it. And they are used for computational efficiency in arithmetic. But it's because of that reason that Python distinguishes the 2. So we have strings and numbers, but as we saw before, it is interesting that you can do arithmetic with strings. They are a variable, so we can add them together, we can concatenate them, we just glue them right together. You can strangely also do multiplication. So let's say we do genus times 3, we get vitis. And you can use combinations of math operations. So let's multiply, and then let's add species. And so what you get is vitis vinifera. So in some ways, strings can work just like numbers, but only so far. So if you divided genus by species, I think that would be really illogical. What would that even be? And indeed, if you try to do that, you will not get far. So let's create some numbers now. So we use this length function to find the length of genus. That's 5. Let's just create a variable. We will call it integer because 5 is an integer. We set the variable integer to the output of the function length on genus, which we know to be 5. And then if we use the type function to figure out what is the variable integer, it is an integer, int. Let's create another variable. We will call it floating point. And we will use 5.1 as an example. And so if we ask Python using the type function, what is the variable floating point, we get back that it is a floating point. And let's create one more variable. We will call it string, and we will put in the value 5 using quotation marks as we have been doing. And again, if you do that, type function with string, as you expect, you get string back. So Python can actually convert between different data types. And this is important because of the requirements of different functions that we will be using later on. You may find yourself needing to convert from an integer to a float or a float to an integer because you're getting an error. So let's try to do that. Let's try to create a new variable called integer to float, because we will try to transform our integer variable into a float. To do that transformation, all you do is you use the function float. So if we shift enter that, and then we try to see what have we created with our new variable integer to float, you can see where initially we had an integer with just 5, now we have 5.0, which is a float. And you can definitely check that with the type function, integer to float, and you can see that we do have a float. So what about the other way? Let's try to convert a float to integer. So we'll create a new variable, and we use the function int, integer, to try to force our floating point variable into an integer. So if we shift enter that, and then we do float to int, you can see that now we have 5. So we started with 5.1. We are forcing a floating point, 5.1, into an integer. The only way that Python can do that is to get rid of the fractional component. So you have to be very careful, because you may convert one data type into a different value than you were expecting, as was done here. What about converting an integer into a string? So we'll use the string function on our variable integer. And so if we look at that value now, you can see, because of these quotes, that we have indeed converted an integer into a string. And you can also do this with a float too. So again, we're going to use the string function, and we have this variable floating point, and we can look at our float now, and we have 5.1 in quotations. So now it is definitely a string. So the final one is a string to an integer. And what would that even look like? We can use our int function again. We have our variable string, and then we get an error. Our string was 5, the actual word 5, F-I-V-E. And there's no good way to convert a bunch of letters into a number. So converting strings into numbers doesn't really work, but converting numbers into strings works very well. And you can convert floats and integers between each other as well. So as long as it makes sense, you can do it in Python using the functions str, int, and float. Just be careful, because sometimes when you convert a float into an integer, you may get different values back. And one last point is that we have been creating lists of just one type of a bunch of strings, but you can create lists that are mixed with different data types. So if we put our integer, floating point, and string variables into this mixed list, we can create this mixed list and see what we have. And there you go. We have an integer, a floating point, and a string. So in this video, we learned how to create lists, how to modify lists, how to create a list of lists. We learned how to index lists, to access specific elements. And then we learned about the different data types in Python. These include strings, and they also include numbers. The numbers are of two types, integers and floats. And it's important that you keep track of which data type you're working with, because as we use different functions later on, they will only accept certain types. And you can convert different types into one of the other using the int, str, and float functions. Thanks for listening, and that's all for this video.